Welcome, stargazer, to the sleepy astronomer. Tonight, we drift gently across the vastness of space to uncover a cosmic mystery. Why are some planets scorched with fire while others sleep beneath a blanket of eternal ice? Is it distance from the sun, their atmospheres, their hearts of molten rock or frozen silence? Before we set off, take a moment to breathe deeply and let your mind float among the stars. And tell me, where in the world are you watching from tonight? Whether you're wrapped in a blanket in Canada, gazing up from a quiet beach in Australia, or relaxing somewhere in between, this journey is for you. Now, close your eyes if you wish. Let the stars guide us. Imagine standing on the edge of a quiet desert at night. The sky stretches endlessly above you, glittering with stars. Each one a distant sun, each one lighting up its own little neighborhood in space. Some planets bask in that starlight, warm gently like a cozy campfire. Others are so far away, they feel nothing but cold, eternal night. In our own solar system, the sun is the great hearth, our cosmic fireplace. Every planet you know or have heard of circles around this glowing sphere of fire. But not all planets feel the sun's warmth the same way. The most obvious reason: distance. The closer a planet is to the sun, the more direct sunlight it receives. It's like standing close to a bonfire. The heat radiates straight into your skin. Mercury, the planet closest to the sun, is scorched by intense solar energy. But as you drift outward through the solar system, from Venus to Earth, Mars, and beyond, that energy spreads out. It thins, like smoke rising into the sky. The planets farther away receive less light, and therefore less heat. But there's something fascinating about this celestial dance of distance. It's not as simple as closer means hotter, and farther means colder. Because space, you see, is not like Earth. There's no air to hold on to warmth. So a planet like Mercury, although very close to the sun, can have extreme temperature swings, from searing hot during the day to freezing cold at night. Without a thick atmosphere to trap the heat, the warmth simply slips away into the dark void of space. Now imagine Earth, floating a comfortable 93 million miles from the sun. Here, we receive just the right amount of solar energy to keep our oceans liquid, our forests green, and our nights, while chilly, rarely deadly. This sweet spot is often called the Goldilocks zone, a place not too hot, not too cold, just right. Keep drifting farther out, past Mars, where the sunlight is dimmer and the winds howl across dry, dusty plains. Farther still to Jupiter and Saturn, gigantic gas planets wrapped in storms and mystery. By the time you reach Uranus and Neptune, the sun is just a tiny pinprick of light in the sky, barely enough to warm a hand, let alone a world. These planets live in an icy twilight, their surfaces and clouds freezing, swirling with chilled gases and frozen winds. But here's the dreamy part. Even distance is not the whole story. Just like on Earth, where the mountains are colder than the valleys and the oceans can hold onto heat for months, planets have their own little quirks. Some generate warmth from deep inside. Some reflect sunlight like a mirror. Some hoard heat in thick blankets of atmosphere. But all of them, fiery or frozen, are first and foremost shaped by where they fall in this great cosmic layout, spinning slowly or swiftly around the same radiant star. And as you close your eyes tonight and think of the space between you and the stars, you might wonder, what if there are other planets, orbiting other suns, tucked into just the right distance, waiting to be discovered? Warm enough for rain, cold enough for snow, and balanced just enough to dream of life. Let the thought drift with you, like stardust in a sunbeam. Let's now drift to the very first planet in our solar system, Mercury. It's the closest world to the sun, a small, rocky sphere scorched by solar fire. But what may surprise you is that Mercury is a planet of opposites, a world of extremes. On one side, it burns like a furnace. On the other, it freezes like the darkest Arctic night. Imagine standing on the surface of Mercury as the sun rises over the horizon. But this isn't the same sun you know from Earth. Here, the sun looks 3 times larger in the sky. Its light is blinding, its heat almost unbearable. The surface temperature can soar to 800 degrees Fahrenheit. That's hot enough to melt lead. The rocks beneath your feet shimmer with heat. There's no shade, no clouds, no breeze, just silence and sunlight. But there's no atmosphere to hold that heat. No comforting sky to soften the sunlight. On Earth, our atmosphere acts like a warm blanket. It keeps temperatures from changing too wildly between day and night. But Mercury has almost no atmosphere at all. It's exposed, vulnerable. And because of this, as the sun slowly sets and night falls, the heat disappears into space, like steam vanishing into cold air. Now imagine you're still standing there as night blankets the planet. The temperature drops. Suddenly, dramatically, in a matter of hours, it plunges to negative 290 degrees Fahrenheit. That's colder than any place on Earth. The once blistering surface becomes a frozen wasteland. And yet, just over the horizon, the sun's fire is waiting to rise again, bringing its unbearable heat back to the surface. This dual nature of Mercury, fiery days and icy nights, is something we rarely experience on Earth. Our world has oceans and wind and weather that move heat around the globe. But Mercury is quiet, still. It holds on to nothing. Whatever the sun gives it during the day, it loses again by night. There's another strange thing about this little planet. Its days are very, very long. One day on Mercury, from one sunrise to the next, lasts about 176 Earth days. That means the sun hangs in the sky for weeks at a time, baking the ground without pause. And then, weeks of darkness follow, where the cold takes over completely. You might expect such a close planet to spin quickly, rushing around the sun. And it does move fast in its orbit. Mercury completes a full trip around the sun in just 88 Earth days. But it rotates slowly on its axis. The result is a strange rhythm, a slow pulse of fire and frost, repeated again and again. And there's one more secret. Deep in the shadows of Mercury's craters, places where sunlight never reaches, scientists have found something incredible. Ice. Actual water ice, hidden in the darkness. How can this be on the planet closest to the sun? Because even here, where sunlight burns so intensely, the absence of atmosphere means that cold shadows stay cold, permanently. Some craters are so deep and steep, sunlight has never touched them. These frozen patches may be ancient, untouched for millions, perhaps billions, of years. So Mercury is more than just a hot rock spinning around the sun. It's a planet of paradox, fire and ice, silence and radiation. It reminds us that in space, things are not always what they seem. The closest planet to the sun is not the hottest overall. Venus, with its thick and suffocating atmosphere, holds that title. But Mercury gives us a different lesson. It shows us what happens when there's nothing to protect you from the sun, and nothing to keep you warm when the sun goes away. A raw, beautiful vulnerability, a world of searing brilliance, and absolute silence. So tonight, as you drift to sleep, think of that tiny world glowing on one side and frozen on the other. A lonely stone in the sky spinning slowly through fire and shadow. And let its quiet rhythm rock you gently, like a lullaby whispered by the stars. Far beyond the warmth of the inner solar system, past the rocky planets and the great gas giants, there lies a world so cold, so distant, that the sun is barely more than a bright star in its sky. This world is Neptune, the eighth and final planet in our solar family. It is a realm of deep blues and silent winds, spinning in darkness nearly 3 billion miles away from the Sun. To visit Neptune in your mind, imagine yourself floating through the outer solar system. Everything grows quieter here. The heat fades. The light dims. Eventually, you arrive at a massive, mysterious sphere. It glows faintly, wrapped in layers of icy clouds. Its color is unlike anything you've ever seen, a piercing blue, like the coldest ocean on the coldest day. But this isn't water. It's a swirling sea of gases, frozen clouds, and winds that never stop blowing. You might expect such a distant planet to be still and lifeless, its energy long since drained away by the cold of space. But Neptune defies expectations. Despite being so far from the Sun, it is alive with motion. In fact, Neptune holds a record. It has the fastest winds in the entire solar system, up to 1,200 miles per hour. That's faster than the speed of sound on Earth. And yet, the Sun provides Neptune with hardly any energy. Its light and warmth arrive in the faintest trickle, only about 1/900th of the sunlight we receive on Earth. So where does all that power come from? Scientists believe that Neptune has its own hidden furnace deep inside. Beneath its thick clouds and dense atmosphere, this icy giant radiates more heat than it receives. It's as if it still holds the ancient warmth of its formation, glowing softly from within like embers buried under snow. This internal heat drives its massive storms and swirling winds, creating a dynamic, restless world in the coldest part of the solar system. But Neptune is also a place of ice. Not the kind you find in your freezer, but exotic, high-pressure ices made from methane, ammonia, and water. These ices don't behave like the ice you know. Deep inside the planet, the pressure is so intense that scientists believe water may exist in a strange, super-hot state, hotter than fire, yet still behaving like a thick fluid. Some even think that it might rain diamonds deep within Neptune's mysterious layers. Imagine that. Shimmering crystals falling slowly through blue clouds, too far away for anyone to ever see. Above, in the upper atmosphere, Neptune wears a necklace of clouds. Methane gas gives the planet its distinctive blue color, absorbing red light and reflecting blue back to space. These clouds shift and swirl, sometimes forming vast, dark storms that appear and vanish over weeks or months. One of these, known as the Great Dark Spot, was once seen spinning across Neptune's face, a storm large enough to swallow the entire Earth. Despite its distance, Neptune continues to fascinate. It pulls at the imaginations of astronomers, dreamers, and poets alike. It's the cold edge of our solar system, the frontier where sunlight fades and mystery begins. And yet, even here, in the coldest reaches of our celestial neighborhood, there is movement, there is power, there is life, not life as we know it, but the life of a planet that breathes in winds and pulses in clouds. Neptune shows us that being cold does not mean being still, that even in the loneliest corners of the cosmos, beauty and energy can exist together. So as you settle deeper into rest, picture Neptune slowly spinning beneath its layers of sapphire haze. Feel the gentle pull of its tides, the swirl of its icy winds, the hum of a planet that sings its song in the silence of deep space. And let that song carry you further into dreams, outward, colder, calmer, with stars above and Neptune below. A world of cold fire, a world of forgotten winds, a world waiting to be known. Now, let us return home. Among the swirling giants and frozen worlds of the solar system, there is one small, vibrant planet that seems to glow with something special. A world wrapped in oceans and clouds. A world alive with wind and music and breath. Earth. It spins gracefully in the so-called Goldilocks zone, not too close to the sun, not too far. Just the right distance to allow rivers to flow, forests to grow, and hearts to beat. It's easy to forget as we walk its surface each day just how rare and delicate this balance truly is. Earth orbits the Sun at an average distance of about 93 million miles. At this range, our planet receives the perfect amount of solar energy, not enough to boil the oceans, not so little that they freeze. And it isn't just distance that makes Earth special. It's the combination of many gentle factors, each playing a quiet, essential role in making this world habitable and comforting. Our atmosphere is one of the most precious ingredients. Composed of nitrogen, oxygen, carbon dioxide, and other gases, it acts like a soft, protective blanket. During the day, it filters harmful radiation, allowing only gentle warmth and light to reach us. At night, it traps enough of that heat to keep the planet from freezing. Without it, our home would face wild temperature swings like Mercury, scorching under the sun and bitterly cold in its absence. And then there's water. Earth is the only known planet with liquid water on its surface. Not just a little, but vast oceans, endless rains, glaciers, lakes, and gentle streams that wind through valleys and forests. Water moderates our temperature. It absorbs heat during the day and releases it slowly at night. It evaporates into clouds and returns as snow or rain. This cycle, quietly repeating over millennia, smooths out the harshness of solar energy, creating seasons, weather, and the soothing rhythm of life. Mountains and deserts, rainforests and coral reefs, all thrive because Earth's climate is not too extreme. Yes, there are storms and droughts, heat waves and freezes, but in the cosmic scale of things, we are extraordinarily stable. That stability has allowed life to blossom in endless forms, from ancient bacteria beneath the sea to the countless species that roam the lands, skies, and oceans today. Even Earth's tilted axis plays a role. At an angle of about 23.5 degrees, it gives us seasons, not just endless summer or endless winter, but a gentle turning of the year, a rhythm that animals, plants, and even human culture have followed for thousands of years. Spring's renewal, summer's warmth, autumn's harvest, winter's rest. And let us not forget the moon. Our silent companion in the sky helps steady Earth's spin. Without it, our planet might wobble too much, causing wild swings in climate and day length. But thanks to the moon's gentle gravitational tug, we enjoy regular tides and a mostly stable rotation. Another quiet note in Earth's perfect song. So why is Earth not fiery hot like Venus or icy cold like Neptune? Because everything, distance, atmosphere, water, motion, works in harmony. It is a living balance, not fixed, but always flowing, adjusting slightly over time. Earth is not static. She breathes, she shifts, she changes, but always within limits that allow life to continue. In the chill of night or the warmth of day, we are held in a perfect embrace. Just enough heat to grow a sunflower, not too much to wither it, just enough cold to bring snow, not so much that all is frozen forever. It is easy to look up at the stars and wonder what else is out there, to dream of far-off planets and alien skies. But sometimes, the greatest wonder is right beneath your feet. This small blue world, spinning softly in the dark, has given you everything. The air you breathe, the ground you walk on, the memories you hold dear. So as you drift deeper into sleep, imagine Earth floating in the velvet dark of space, a gentle marble swirled with clouds, a home warmed not only by the sun, but by balance, by rhythm, and by the quiet miracle of being just right. Let your heart rest in that thought. You are cradled by the most precious planet we know, a world of wind and waves, of sunlight and sleep, a world that, despite all its changes, still whispers the same lullaby it has sung for billions of years. And tonight, that lullaby is yours. Let us now drift to a planet that looks serene from far away, shining gently like a pearl in the morning sky. But up close, it is a place of unimaginable heat and crushing pressure. This is Venus. Second from the Sun, Venus is often called Earth's sister planet. And at first glance, they do seem alike, similar in size, gravity, and composition. Both are rocky worlds, both have clouds. But beneath the soft glow of Venus's atmosphere lies one of the most extreme environments in the entire solar system. To understand Venus, we must begin with its atmosphere. Unlike Earth's life-supporting air, Venus's atmosphere is thick and heavy. So heavy, in fact, that standing on its surface would feel like being 1 kilometer deep in the ocean. The pressure would crush you instantly. And what fills this crushing air is not oxygen, but carbon dioxide, over 96% of it. The clouds, rather than bringing gentle rain, are made of sulfuric acid. The skies are yellow and toxic. No breeze, no relief, just heat and pressure and poison. And then there is the temperature. Despite being farther from the Sun than Mercury, Venus is the hottest planet in the solar system. Surface temperatures reach around 900 degrees Fahrenheit, hot enough to melt lead, hot enough to destroy even the toughest spacecraft in a matter of hours. But why is it so much hotter than Mercury, which is closer to the Sun? The answer lies in its thick atmosphere. Venus is trapped in a runaway greenhouse effect, a planetary fever that never breaks. Sunlight passes through the atmosphere, reaches the surface, and warms it. But the heat can't escape. The dense clouds and carbon dioxide act like a perfect insulating blanket, wrapping the planet in layer upon layer of trapped energy. Every ray of sunlight that enters is caught and magnified, creating a self-reinforcing cycle of heat that has been raging for millions of years. There is no nighttime cooling, no seasons, no gentle shifts in weather, just constant, unrelenting heat. Imagine walking through a dense fog that burns your skin, presses on your chest, and blocks your view. That is the reality of Venus. A world where day and night barely make a difference, where the skies never open, and where the surface is hidden beneath a ceiling of permanent cloud. And yet those clouds reflect sunlight so effectively that Venus appears bright in our sky. The planet shines in the early morning and late evening like a star of hope. Ancient civilizations called it the morning star, the evening star, even associating it with love and beauty. Little did they know that beneath that radiant glow was a world of fire. Adding to the strangeness is Venus's rotation. It spins incredibly slowly. One day on Venus lasts longer than its year. Even more unusual, it rotates backward compared to most planets. If you stood on the surface, in a hypothetical heat-proof suit, you would watch the sun rise in the west and set in the east. But you would wait a very, very long time to see it. The planet turns so slowly that its day lasts about 243 Earth days, while its year is only about 225 Earth days. In other words, a day on Venus is longer than a year. Volcanoes dot its surface, thousands of them. Some are massive, stretching for hundreds of miles. Though many are likely extinct, there's evidence that Venus may still be volcanically active. The ground may tremble, lava may still flow in silence beneath those suffocating clouds. Venus is a warning, a mirror held up to Earth showing what could happen if a planet's climate spins out of balance. It likely once had water, perhaps even oceans. But something changed. As the sun grew slightly warmer over time, Venus may have reached a tipping point. The oceans evaporated, water vapor trapped more heat, and the greenhouse effect spiraled. What was once a place of potential turned into a furnace, a lost twin. A vision of beauty, wrapped in silence and storm. So now, as you rest, picture this planet not as a threat, but as a lesson from the universe, a reminder of how delicate life is, how finely tuned our own world must be to sustain the gentle rhythms we rely on: wind in the trees, snow in winter, the soft pulse of rain on a window. Venus drifts not far from us in cosmic terms, but its fate is very different. A place where warmth has no end, where the air presses like 1,000 hands, and where no life, as we know it, could ever bloom. But even so, it remains a jewel in the sky, a quiet contradiction, beauty wrapped in fire. Let the image settle in your mind, a world wrapped in golden clouds, spinning slowly in silence, forever whispering the story of what happens when the balance is lost. And as your thoughts return to Earth, let that whisper remind you: our planet is precious, our skies are fragile, and the balance that keeps you safe and cool under the stars is a gift worth treasuring. Let that truth settle gently into your dreams, like a feather floating through starlight. In the great story of planetary temperatures, there's one chapter that quietly shapes nearly everything: the atmosphere. It may seem invisible, even forgettable, but this thin veil of gases that surrounds a planet is one of the most powerful forces in all of nature. It can create burning heat or chilling cold. It can cradle life or choke it out. It can be the gentle breath of a world or its smothering curse. Let your mind float now to Earth. You've felt the atmosphere every day of your life, even if you don't often think about it. It carries the breeze that cools your skin. It holds the clouds that give us rain. It shields you from the sun's dangerous rays and traps enough warmth to let flowers bloom. But this same process, this delicate act of holding and releasing heat, is what determines whether a planet bakes or freezes. It all begins with sunlight. When the sun's rays strike a planet, some of that energy bounces off right away, especially if the planet is covered in shiny surfaces like ice, snow, or clouds. But much of it is absorbed by the ground, the oceans, or the clouds. That energy warms the planet, and then, slowly, invisibly, the planet radiates some of that warmth back into space in the form of infrared radiation, or heat. Here's where the atmosphere plays its quiet trick. Certain gases, called greenhouse gases, act like the glass of a greenhouse. They let sunlight in, but they don't let all the heat escape. These gases, such as carbon dioxide, methane, and water vapor, trap some of that outgoing energy and send it back down, warming the planet's surface even more. This is called the greenhouse effect. On Earth, this effect is just strong enough to keep our planet in a comfortable temperature range. Without it, Earth's average temperature would be far below freezing. Life, as we know it, might never have emerged. But on other planets, the story changes dramatically. Take Venus. Its thick atmosphere is made almost entirely of carbon dioxide with layers of sulfuric acid clouds above it. Sunlight gets in, but almost none of the heat gets out. The result: a surface hot enough to melt metal. Venus is an example of the greenhouse effect gone wild, an atmospheric trap that never lets go of the sun's fire. Now travel to Mars. Here, the atmosphere is incredibly thin, less than 1% the thickness of Earth's. It also contains mostly carbon dioxide, but there's not enough of it to trap much heat. Even when the sun shines, the warmth escapes quickly. That's why, even though Mars can be sunny during the day, temperatures plummet at night. The planet simply can't hold on to its heat. Then there's Jupiter, Saturn, Uranus, and Neptune, the gas giants. These planets have massive, thick atmospheres made mostly of hydrogen and helium. They don't have solid surfaces like Earth, but their clouds and gases behave in complex ways. Some layers trap heat, others release it. Some scientists believe these planets also radiate heat from their cores, remnants from their formation long ago. Their atmospheres are swirling tapestries of storms and pressure systems, each shaped by how heat flows within them. Even Mercury, which barely has an atmosphere at all, reminds us how important it is. On Mercury, the lack of an atmosphere means that sunlight hits the surface directly, and at night, all that heat escapes back into space. That's why Mercury experiences some of the most extreme temperature swings in the solar system, from over 800 degrees Fahrenheit during the day to below -290 at night. So we see again and again that an atmosphere is more than just air. It is a planet's thermal memory. It decides how long a world holds onto the sun's warmth and how quickly it lets go. On Earth, even small changes in the atmosphere can make a big difference. Human activity has increased the amount of greenhouse gases, especially carbon dioxide. This has caused our planet to warm slowly but steadily, altering weather patterns, melting glaciers, and changing ecosystems. We are witnessing, in real time, how even a thin layer of gas can change the course of a planet's story. But atmosphere isn't just about temperature. It also shapes how a planet feels, smells, and sounds. On Earth, air carries birdsong and whispers through trees. On Venus, the thick atmosphere would make sound travel faster and deeper, but you'd never hear it through your helmet. On Mars, with its thin air, even a shout would sound like a whisper. Each planet's atmosphere is a reflection of its history, its chemistry, and its place in the solar system. And each one tells a different tale about how heat is held, lost, or transformed. So tonight, as you lie back and breathe softly, know that the air around you, the air you inhale with each peaceful breath, is not just something to fill your lungs. It is a gift, a gentle, life-giving force that keeps you warm, safe, and connected to the Earth itself. Let the quiet miracle of that thought settle into you. You are held in the arms of an atmosphere perfectly suited for life. And all around you, drifting through the cosmos, are other worlds, each wrapped in their own invisible layers, whispering their own stories of fire, frost, and air. Sleep now in the shelter of your planet's breath, the same breath that warms you gently, just enough, through the long and star-filled night. Now let us drift farther still, beyond the rocky worlds and the warm embrace of the inner solar system, into the realm of the gas giants. Massive planets made not of stone or soil, but of gas, clouds, and storms that have been raging for billions of years. Here, in the cold outer reaches of the solar system, it might surprise you to learn that some planets are warm not because of the sun, but because of something deep within themselves. Take Jupiter, for example, the largest planet of them all. It's more than 300 times more massive than Earth, and yet, despite being so far from the sun, it radiates almost twice as much heat as it receives. Imagine that. A planet so large, so powerful, that it glows from the inside out. But where does this internal heat come from? To understand, we need to look back, way back, to the birth of the solar system. Around 4.6 billion years ago, a giant cloud of gas and dust collapsed under its own gravity. The center of that collapse became the sun, and the swirling leftovers formed the planets. Jupiter, being so massive, pulled in enormous amounts of gas, hydrogen, helium, and other elements. As this gas fell inward under Jupiter's gravity, it compressed and heated up. That heat has been slowly leaking out ever since. Even now, after billions of years, Jupiter is still warm on the inside. Its massive core and the layers of gas above it continue to release energy. This is not fire in the traditional sense. It's not burning. It's the heat of ancient gravity still echoing through time. Saturn, too, radiates more heat than it receives. But Saturn has its own special trick. Deep within its atmosphere, scientists believe helium is slowly separating from hydrogen. This process, called helium rain, releases heat as the helium droplets fall toward the core, like golden rain in a planet-sized thunderstorm. This ongoing descent of helium adds to Saturn's internal warmth, glowing gently beneath its famous rings. These hidden sources of heat drive the giant planet's weather systems. On Jupiter, they power the Great Red Spot, a massive storm larger than the Earth that has raged for centuries. On Neptune, the coldest major planet in the solar system, internal heat fuels some of the fastest winds ever measured, blowing faster than the speed of sound. Even Uranus, which appears unusually quiet and cold, likely once had more internal heat, but something may have disrupted its energy flow long ago. Perhaps a colossal impact in its distant past knocked it sideways, both literally and thermally. Uranus rotates on its side, with its poles facing the sun more than its equator. This odd tilt may have influenced how its heat escapes, making it the most mysterious of the gas giants. But what does this all mean? It means that the warmth of a planet is not only determined by the sun's light. There is fire in the darkness, hidden heat that comes from within. While Mercury bakes in sunlight and Neptune shivers in distant starlight, Jupiter glows with the energy of its own birth. Saturn radiates the warmth of falling helium. These giants are like embers in a dying fire, cool to the touch on the outside, but alive with warmth inside. And this internal heat matters. It stirs the gases, it shapes the clouds, it fuels the storms that twist across their faces like cosmic hurricanes. Without it, these planets would be still, silent balls of frozen gas. But instead, they are dynamic, churning, breathing giants. Even some of their moons feel the warmth. Jupiter's moon Io, for instance, is the most volcanically active place in the solar system, not because of the sun, but because of Jupiter's gravity, which kneads and squeezes it like clay, generating enormous heat from within. Europa and Enceladus, other icy moons, may have hidden oceans of liquid water beneath their surfaces, warmed not by sunlight, but by the deep, rhythmic tug of their parent planets. So here, in the coldest parts of the solar system, we discover that not all warmth comes from above. Some of it comes from below, from the deep heart of a planet, from the pressure of its gravity, from the dance of its atoms, from the leftover heat of creation itself. As you relax into the quiet of the night, think of these giants, far away, nearly invisible, spinning slowly in the dark. They glow with their own gentle warmth, a kind of planetary heartbeat pulsing quietly through space. They remind us that even when the light fades, warmth can endure. Even when all seems frozen, something may still burn inside. Let that thought warm you tonight, like a hidden ember beneath a blanket of stars, a quiet glow that says, even in the dark, life stirs, energy lingers, and the universe is never truly still. In the grand ballet of planets and stars, there are smaller dancers, quieter companions, that often go unnoticed. These are the moons, silent, drifting worlds that orbit their planetary parents, like children trailing behind. And while they may seem passive, many moons have stories just as dramatic, just as astonishing as the planets they orbit. Some are scorched, others frozen. Some erupt with fire, others sleep beneath blankets of ice, and all of them live under the powerful influence of their host planets, caught in a delicate tug-of-war between light, shadow, heat, and cold. Imagine standing on the surface of a moon, far from Earth, looking up at the enormous planet it orbits. It would fill half the sky, glowing with reflected sunlight and cloaked in swirling clouds. You'd feel the faint pull of gravity, not from the distant sun, but from the giant world above you. You might be standing on one of Jupiter's many moons, or perhaps orbiting Saturn, Neptune, or even the icy shadows of Uranus. Moons are deeply affected by their environments. Unlike planets, most moons do not have thick atmospheres. Many are small and airless, with surfaces covered in craters, scars from millions of years of silent collisions. Without atmospheres to trap heat, these moons are subject to extreme temperatures. When exposed to sunlight, they can grow surprisingly warm, especially near the equator. But once they rotate into the darkness, they cool rapidly, becoming as cold as -300 degrees Fahrenheit or lower. There is no blanket of air to hold onto the warmth, just emptiness and cold. But not all moons are cold and quiet. Some of them are alive. Take Io, for example. It's one of Jupiter's 4 largest moons and the most volcanically active body in the solar system. Its surface is constantly shifting, bubbling, and erupting, not because of internal heat alone, but because of gravitational friction. As Io orbits Jupiter, it's tugged by the planet's immense gravity, and also by the pull of neighboring moons. This back and forth stretching creates tidal heating, generating immense internal energy. Instead of freezing, Io burns. Its volcanic plumes shoot hundreds of miles into space, painting the sky with sulfur and ash. Farther out, there's Europa. Also orbiting Jupiter, it's much colder on the surface. A thick shell of ice covers the moon, reflecting the sun's light like a mirror. At first glance, it seems frozen, still, lifeless. But beneath that icy crust, scientists believe there may be a vast ocean of liquid water, kept warm not by the sun, but by that same tidal tugging from Jupiter's gravity. This hidden ocean may be more than 60 miles deep, potentially harboring more water than all of Earth's oceans combined. And where there is water and warmth, even if it comes from inside, there is the possibility of life. Saturn's moon Enceladus tells a similar tale. Though only a few hundred miles across, this tiny moon has captivated astronomers. Its icy surface is cracked and fractured, and from those cracks, geysers of water vapor and ice shoot into space. These plumes suggest that Enceladus too holds an internal ocean. As it orbits Saturn, the push and pull of gravity creates friction in its core, generating heat, enough to melt ice and maintain a liquid sea beneath its frozen surface. Then there's Titan, Saturn's largest moon and one of the most Earth-like bodies in the solar system, at least on the surface. Titan has a thick atmosphere, mostly nitrogen, and clouds that drizzle methane instead of water. Lakes and rivers made of liquid hydrocarbons dot its landscape. Though far colder than Earth, Titan has weather, erosion, and even seasons. The sun barely reaches it, but its atmosphere helps retain some warmth, creating a slow alien version of Earth's own climate systems. Moons are also shaped by their positions in the shadows and light of their planetary parents. Some are tidally locked, meaning one side always faces the planet, while the other faces away, trapped in eternal night. This can cause striking temperature differences between the two hemispheres. The side facing the planet may be warmer, due to infrared radiation bouncing off the gas giant, while the far side may be far colder. The dance between shadow and light becomes a permanent fixture of their world. And let us not forget our own moon. It, too, is tidally locked, with the same side always turned toward Earth. Without an atmosphere, temperatures on our moon swing wildly, from boiling during the long lunar day to freezing at night. But unlike the moons of Jupiter and Saturn, our moon is quiet now. Its volcanic days are long past. It is a still observer of Earth, reflecting our light and influencing our tides. Moons remind us that not all warmth comes from the sun. Some of it comes from movement, from gravity, from the ceaseless pull of one object upon another. Moons are heated by invisible forces, warmed by friction, touched by light only briefly, and yet they glow with mystery and potential. They may be small, but they are not insignificant. In their icy crusts and hidden seas may lie the next great discoveries. clues to the origins of life, or to the strange and beautiful diversity of worlds beyond our own. So as you drift deeper into sleep, imagine these silent travelers orbiting in darkness, some erupting with fire, others whispering with water, all of them wrapped in the gravitational arms of their parent planets, warmed and shaped not by sunlight alone, but by invisible forces that stir from within. Let the thought comfort you that even in the shadows of giants, warmth can be found, even in the farthest corners of space, where no sunlight shines, motion itself creates life, and that sometimes the smallest worlds hold the greatest secrets. Let the moons cradle you now, as they cradle their planets, silent, turning, dreaming, forever caught in the gentle pull of something greater. Out in the vast quiet of space, where cold and heat war for dominance, and the distances between stars stretch into the millions of miles, there exists a narrow band, a golden thread woven delicately around each star. This thread is not drawn in fire or stone, but in temperature and time. Astronomers call it the habitable zone, but many prefer a simpler, gentler name, the Goldilocks zone. It's the place in space where a planet is neither too hot nor too cold, but just right for liquid water to exist on its surface. And where there is water, there might be life. Imagine walking through the story of Goldilocks once more, not in a cottage with bowls of porridge, but in a solar system with planets instead of chairs, stars instead of beds. One planet is too hot, its atmosphere smothering, its surface boiling. Another is too cold, its ground locked in ice, its air too thin to breathe. But one, perhaps just one, rests in that perfect middle ground, warm enough to keep water flowing, cool enough to keep it from boiling away. That is where Earth lives, in the sweet center of the Goldilocks zone around our sun. It's a narrow place, really. If Earth were just a little closer to the sun, say where Venus sits, our oceans might have evaporated and our atmosphere might have turned into a choking trap of carbon dioxide. If Earth were just a little farther away, like Mars, the temperatures could drop so low that water would freeze solid year-round, leaving behind dust and silence. But we're not there. We're here. Suspended between fire and frost, cradled by sunlight that is soft enough to warm but not scorch. We are just right. The Goldilocks zone is not the same for every star. Around larger, hotter stars, the habitable zone lies farther out, like a distant ring warmed by an intense glow. Around smaller, cooler stars, the zone moves inward, closer to the hearth of light. For some stars, like tiny, dim red dwarfs, the habitable zone is so close that a planet may become locked in a strange rhythm, with one side always facing the star and the other side shrouded in eternal night. But even in these unusual places, there may be hope. For planets that spin slowly or have thick atmospheres, warmth might still circulate, oceans might still move, winds might still whisper, life might still bloom, sheltered in the shadows or hidden beneath the surface. This is why the Goldilocks zone has become one of the great quests of modern astronomy. Telescopes scan the skies for planets that lie in this gentle band around other stars. We call these worlds exoplanets, and already we've discovered thousands. A few are rocky, like Earth. Some may have water. A handful lie in just the right orbit, neither too near nor too far. We do not know yet if any of them are truly like our world, but the thought alone is powerful. Somewhere, many light years away, there could be a planet warmed by a friendly star, where clouds drift over forests or seas, where rain taps gently on rocks, and where, perhaps, something stirs beneath the surface. Something living, something dreaming. Back in our solar system, Earth stands alone in this zone. Venus is too close, Mars too far. Though Mars is tantalizingly near the edge, Its thin atmosphere and cold climate keep it from holding water for long. But perhaps, long ago, Mars was different. There is evidence that rivers once flowed there, lakes once shimmered under the sky. For a time, Mars may have been in its own Goldilocks moment, until something changed. The Goldilocks zone is not just about where a planet is, but also when. A planet can pass through it over time. A world that is frozen today may one day thaw as its star grows warmer. A world that is perfect now may one day become too hot as its star slowly expands and ages. Even Earth, our gentle home, will not stay in this zone forever. Billions of years from now, the sun will swell and Earth may grow too hot for life. Our planet's place in the zone is temporary, but beautiful. That's what makes it all so precious, to be alive right now, on a planet resting in the Goldilocks zone. To have oceans that dance with moonlight, forests that rustle with wind, and skies that carry the warmth of the sun. This is a miracle of cosmic timing. So as you close your eyes and rest, imagine the universe not as cold or empty, but as a vast field of possibility. Imagine distant stars, each with their own golden ring. Within those rings, small worlds spin, some empty, some quiet, some perhaps waiting. And here we are, on our own spinning world, warmed by just the right amount of light, cooled by just the right amount of shadow. You are part of a planet that is just right. Let that truth settle into you. Let it soften your thoughts and carry you gently into dreams. You are living in the most fortunate sliver of space and time, a world not too hot, not too cold, a world made for life, a world made for you. As we come to the end of our celestial journey, drifting gently through the quiet beauty of the cosmos, it's time to step back, to rise slowly above all the individual planets, their temperatures, atmospheres and hidden fires, and to see the bigger picture. What does it all mean? Why are some planets fiery hot while others are icy cold? Why do some shimmer with warmth while others sleep beneath frozen skies? And what do these distant worlds tell us, not only about the universe, but about ourselves? In truth, the differences in planetary temperatures are shaped by many delicate, intertwining forces. Distance from the sun, the thickness of the atmosphere, the composition of each planet's surface, the tilt of its axis, its rotation, its moons, and even the heat that stirs silently from its core. Each world is a complex poem written by gravity and time, spun from gas and dust, cradled in invisible fields of light and magnetism, and each one has found its own balance, or imbalance, between heat and cold, between fire and ice. Some, like Mercury, are exposed and vulnerable, their faces scorched by day and frozen by night. Others, like Venus, wear a cloak of cloud so thick it traps heat forever, turning the planet into an eternal furnace. Some, like Mars, hover on the edge, dry and desolate now, but perhaps once wet and warm, waiting for another chance to awaken. And still others, like Jupiter and Neptune, glow faintly from within, warmed not by the sun, but by ancient energy that still pulses from their birth. Even their moons are alive with quiet contradictions, some bursting with volcanic fire, others sleeping beneath ice, warmed only by the steady tug of gravity. These extremes, these shimmering contrasts, are not mistakes. They are not flaws. They are part of a cosmic design as rich and mysterious as the night sky itself. What we learn from these planets is that the universe is not uniform. It does not offer every world the same conditions, the same gifts, or the same story. Instead, it creates diversity. It creates contrast. And it is in this contrast that beauty is born. Without fiery planets, we would not understand the power of heat. Without icy worlds, we wouldn't grasp the silence of cold. Without darkness, we wouldn't appreciate light. And without lifeless places, we might never recognize how precious life truly is. Our Earth, spinning gently in the middle of all this, is rare, not because it exists, but because it thrives. It is a place where the contrasts have found harmony, where warmth is balanced by coolness, where water can flow, clouds can gather, and life can flourish. This delicate balance is not guaranteed. It is not fixed. It is something we must honor, protect, and cherish. Because the more we look out into space, the more we understand just how lucky we are to be here, on a planet where forests breathe, oceans sing, and hearts beat beneath the stars. But the story doesn't end there. Because these extremes, the fire, the frost, the wind, and silence, also remind us of something more personal, something deeply human, that we too are shaped by contrast. We know joy because we've felt sorrow. We treasure warmth because we've known cold. We seek comfort because we've faced discomfort. Just like the planets, we hold fire within us, and we also carry stillness. Some days we shine, like Venus in the sky. Other days we drift quietly, like Neptune in the dark. Some parts of us are bright and full of life. Others are shadowed, waiting to be explored. But all of it, all the fire and all the ice, makes us whole. So when you look up at the night sky, remember this: you are part of this universe, made of the same stardust as the planets, held by the same laws, spinning through the same darkness. The sun that warms Mercury is the same sun that kisses your skin. The gravity that stirs the oceans also pulls gently at your feet. You are not separate from the cosmos. You are a thread in its endless tapestry. And that perhaps is the greatest meaning of all. The planets teach us about balance. They remind us that beauty can take many forms, that warmth can come from a distant star or from deep within, that cold is not lifeless, that silence is not empty, that extremes can coexist and still create something profoundly meaningful. So as you settle into the quiet of your night, let the planets keep watch over your dreams. Let their ancient rhythms soothe your thoughts. Let their contrasts remind you of your own strength, your own softness, your own mystery. In the end, the fire and the frost are both part of the same dance. A dance that spans light years, a dance that echoes in your breath. You are part of a universe full of worlds, each one different, each one extraordinary. And tonight, as you rest, the cosmos rests with you.